We want dimensional formula of B by mu naught. We know the formula. B is equal to mu naught Ni, and this formula is for solenoid magnetic field. Here we want B by mu naught dimensional formula. Here N is number of turns per unit length, so we can say capital N by L I. N is a constant, so we want dimensional formula of B by mu naught is equal to, N is a constant, you can remove the constant dimensional formula. There is no dimensional formula for a constant. So N dimensional formula is ampere by L. So finally it is A power N, A power 1, L power minus 1. So option 2 is the correct answer. Sphere of mass M of radius R. So there is a sphere of mass capital M and radius capital R. Exert a force F on the point mass. So there is a point mass. Now the spherical mass, the sphere, see, first force we find out F is equal to G capital M. Point mass is there, let it is small m, mass is the small m, by distance between them is r square. So gravitational force formula, F is equal to G m(m)2 by r square. Now what he is saying, now the spherical shell of mass m by 7 is removed with the, what is the new force? So now what he did, so there is some mass is removed from it, let it be, this part is removed. Now its m by 7 mass is removed. So now new mass, what is the new mass will be? New mass will be m minus m by 7, m minus m by 7. So what it becomes, m by mass is removed. So if you do LCM, it will be 7m minus m by 7. It is 6m divided by 7. This mass is now new mass. So then the new force will be, F dash will be capital G. The new mass is 6m by 7 Gm small m by distance is same, r square. So F dash is equal to, you see, 6 by 7 times of G capital M small m by r square it is, yes or no? So this value is F. So we will get F dash is equal to 6 by 7 times of F. So option 2 is the correct answer. Find out equivalent capacitance for the situation shown in the figure. See here, this is one dielectric constant K1, K2 and K3, 3 are given. The distance between the two plates of the capacitor is D and the area is A. In that, it has divided into 3 parts. This situation is something like this. Here you can take 3 capacitors. This is the first capacitor, okay, and second capacitor. Now these two capacitors are, whose dielectric constant is K1 and dielectric constant is K2. This distance you see it is divided into half of. So it is d by 2 and this is also d by 2. Distance is half of. Area also you see half of it is divided. This, its capacitor area is A by 2. This capacitor area also A by 2. Now there is one more capacitor which is connected to parallelly to these capacitors. So you got something. This is dielectric constant K3, distance is D, area is A by 2. So what is the resultant capacitance of these 3? So first these two capacitors are in series. So C1 and C2 are in series. Series formula, 1 by C equivalent is equal to 1 by C1 plus 1 by C2. C is equal to epsilon naught A by D, 1 by K times of epsilon naught A by D. It's K1 epsilon naught. A is half, okay, A by 2, you see, A by epsilon naught A by D, D will come up, you see. This is the 2 for this capacitor A, distance and D, and there is another half. A by 2 will go up, D by 2 plus same here 2D K2 epsilon naught A2. See, K epsilon naught A by 2 by D by 2. So you see 2 to cancel, 2 to cancel. So what we will get, 1 by C is equal to, it is D by epsilon naught A common. So you will get around 1 by K1 plus 1 by K2. So this value I got. So let's do LCM. 1 by C is equal to D by epsilon naught A. So it is K1 plus K2 by K1 K2 we got. So I want C is equal to epsilon naught A by D into K1 K2 by K1 plus K2. Now this is in parallel with the third capacitor C3. So C and C3 are in parallel. In parallel, just add it. So final C equivalent is equal to C plus C3. What is C? C is epsilon naught A by D K1 K2 by K1 plus K2 plus C3. C3 K times of epsilon naught A. A is half by D. D is same. See, K times of epsilon naught A is half, D is D. I have taken here. Now you see, in these two, epsilon naught A by D I am taking common. So that will become K1 K2 by K1 plus K2 plus K3 by 2. So that will be the answer. So epsilon naught A by D, three options are there. You should take the LCM here. So K1 K2, 2 K1 K2 will come. I think, see, very clearly it is visible if you take LCM here. Epsilon naught A by D, if you take 2 K1 K2 plus K3 times of K1 plus K2, you see here K LCM by 2 into K1 plus K2. So this is the option, right? Correct. So epsilon naught A by 2D K1 plus K2. Oh, here 2 K1 not there. 2 K1 K2 should be right. So this is the answer. 2 K1 K2, K2 K3, K1 K3, K2 K1 K2. Here 2 K1 K2. This is the option 2 is the answer. Find out equivalent capacitance for a situation shown in the figure. See here, this is one dielectric constant K1, K2 and K3, 3 are given. The distance between the two plates of the capacitor is D and the area is A. In that, it has divided into 3 parts. This situation is something like this. Here you can take 3 capacitors. This is the first capacitor, okay, and second capacitor. Now these two capacitors are whose dielectric constant is K1 and dielectric constant is K2. This distance you see it is divided into half of. So it is D by 2 and this is also D by 2. Distance is half of. Area also you see half of it is divided. This its capacitor area is A by 2. This capacitor area also A by 2. Now there is one more capacitor which is connected to parallelly to these capacitors. So you got something. This is dielectric constant K3, distance is D, area is A by 2. So what is the resultant capacitance of these 3? So first these two capacitors are in series. So C1 and C2 are in series. Series formula 1 by C equivalent is equal to 1 by C1 plus 1 by C2. C is equal to epsilon naught A by D, 1 by K times of epsilon naught A by D. It's K1 epsilon naught. A is half, okay, A by 2, you see, A by epsilon naught A by D. D will come up. You see, this is the 2 for this capacitor A, distance and D, and there is another half. A by 2 will go up, D by 2 plus same here 2D K2 epsilon naught A2. See, K epsilon naught A by 2 by D by 2. So you see 2 to cancel, 2 to cancel. So what we will get, 1 by C is equal to, it is D by epsilon naught A common. So you will get around 1 by K1 plus 1 by K2. So this value I got. So let's do LCM. 1 by C is equal to D by epsilon naught A. So it is K1 plus K2 by K1 K2 we got. So I want C is equal to epsilon naught A by D into K1 K2 by K1 plus K2. Now this is in parallel with the third capacitor C3. So C and C3 are in parallel. In parallel, just add it. So final C equivalent is equal to C plus C3. What is C? C is epsilon naught A by D K1 K2 by K1 plus K2 plus C3. C3 K times of epsilon naught A. A is half by D. D is same. See, K times of epsilon naught A is half, D is D. I have taken here. Now you see, in these two, epsilon naught A by D I am taking common. So that will become K1 K2 by K1 plus K2 plus K3 by 2. So that will be the answer. So epsilon naught A by D, 3 options are there. You should take the LCM here. So K1 K2, 2 K1 K2 will come. I think, see, very clearly it is visible if you take LCM here. Epsilon naught A by D, if you take 2 K1 K2 plus K3 times of K1 plus K2, you see here K LCM by 2 into K1 plus K2. So this is the option, right? Correct. So epsilon naught A by 2D K1 plus K2. Oh, here 2 K1 not there. 2 K1 K2 should be right. So this is the answer. 2 K1 K2. The curvature of the common surface of the two bubbles R1 and R2. See, R1 is radius is bigger, R2 radius is smaller, and these are two soap bubbles. They have their pressure differences. Because of that, it forms a common surface. So what is the pressure difference of P1 with atmosphere? See, concave side will be higher pressure, right? So delta P in the first one is equal to 4S by R1, okay? And in the second one will be, here again the more pressure will be. So delta P2 will be 4S by R2. So here the pressure will be, the second one and the first one. See, now the both have the difference. R2 is smaller, so pressure will be higher. R1 is bigger, the pressure will be smaller. So there will be a pressure difference. And that pressure difference is delta P2 minus delta P1. That pressure difference is how much? 4S by R equivalent it will form. And how much we know? We know this is 4S by R2 we got minus 4S by R1 we got. Cancel 4S. So 1 by R equivalent is equal to 1 by R2 minus 1 by R1. Take LCM. 1 by R equivalent is equal to R1 minus R2 by R1 R2. So finally R equivalent will be R1 R2 by R1 minus R2. R1 R2 by, so third option is the correct answer. Thank you. From the given option, identify diode connected in forward bias. See, a PN junction diode have two terminals, a P terminal and an N terminal. It is in forward bias when voltage across the P should be greater than voltage across the N. Ulta, reverse will be reverse bias, right? Now let's see. First, here the voltage is 0, P type, and here minus 15. So this is greater, minus 0 is greater, 0 is greater than minus 15. So this is lesser, you see, 2 is less than 4, less, minus 10 is lesser, minus 3 is lesser. So first option, that is correct. Case of electron in hydrogen in the ground state for hydrogen is A0. Okay, radius formula 0.529 n square by z in terms of angstroms. So for hydrogen, radius given as A0 is equal to some constant 0.529, n value, ground state it is 1 square 1, z is 1. So A0 value we got. Now next you do the radius of electron helium third excited state. So again R is equal to 0.529 and third excited state means fourth state it is 4 square 16 by z value helium 2. So R is equal to, it is 8 times of 0.529. This is for helium. So this value they are saying it is A. So they want A0 by A is the question. A0 value we got 0.529 and A value we got 8 times of 0.529. 0.529, 0.529 cancel. Option fourth is the correct answer. Ice at minus 10 degrees Celsius be converted. So there is ice minus 10 degrees Celsius. Minus 10 degrees Celsius is converted into steam. Okay, is converted into steam. Finally, it should go to 110 degrees Celsius. So how it will go of ice of mass given? Some mass will be amount of heat required. So first when you give the heat, it will be ice only. Okay, it was ice, it will be ice only till 0 degrees Celsius. So the temperature change. So apply the formula Q is equal to ms delta T. M value how much given? 10 power minus 3. Specific heat of ice 1 by 2. Delta T temperature, change in temperature is 10 degrees. So it is 5 into 10 to the power of minus 3 joules. Oh, it is in joules. Let's calories, half calorie, no, it is 1 by 2 calories. Gram. Oh, okay. Now I want mass also in grams only. Okay. So because this is half calorie per gram. So no issues. This I need in grams only. Put it as 1. It is as 1 gram. So it is simply answer 5. 5 calories is required. And then you see now this ice will become water. Water at 100 degree, water at 0 degrees Celsius. Now temperature is not increasing, so use the formula ml. ml formula, m value how much? 1 gram into latent heat of water. It is 80 calories per gram. So it is 80. So 80 plus 5, 85 till now. Now it will reach to water again at 100 degrees Celsius because the boiling point of water is 100 degrees Celsius. Now temperature increased, use the formula ms delta T. M value 1 gram, specific heat 1 of water, delta T 100. So it is 100 calories required. Now it will reach to steam at 100 degrees Celsius. Okay. So we can do steam at 100 degrees Celsius. So again formula ml, m value 1, L value 540 calories. So it is 540. Then again it is reached to 110 degrees Celsius. Correct? Again temperature is changing. So use the formula ms delta T. M value 1, specific heat of steam is half, change in temperature 10. So this is again 5. So total we got 540, 640, 640 plus 80, 720, 730. So finally total calories are 730 calories of heat is required. To convert charge, place at the edge of the imaginary cube of side A, this side A, as shown in the figure. Find the net flux passing through the cube. See, we have a formula. Flux is equal to Q inside by epsilon naught. See, if this is at the center of the cube, then flux flows from that cube is Q by epsilon naught. But this Q is not on the center of the cube. It is not closed. It is not enclosed. So now you have to enclose it. See how we enclose it. So with this, by keeping the four cubes, you can enclose this charge. So totally 4 cubes are required to enclose this charge. Okay. Here you can think, here it is back side, here it is the cube. Here this is the 2R on the back side. So it is enclosed. It is enclosed. Here is the charge, you can imagine. So 1, 2, 3, 4. 4 cubes are there totally. So what is the formula? These 4 cubes together flux is Q by epsilon naught. So for each cube, 1 cube, for 1 cube it will be 1/4 of it. So flux in the each cube is equal to 1/4 of Q by epsilon naught. So option 2 is the correct answer. Organ pipe, closed pipe, right? Ninth harmonic. So closed pipe frequency formula, F0 formula, V by 4 times of its length. Ninth harmonic formula, so F in ninth harmonic is equal to 9V by 4, 9V by 4, length of closed given 10. Okay, fine. With harmonica resonates with fourth open organ pipe. See, this is for closed, and for open, F for open pipe is equal to V by 2L, and they are saying fourth harmonic, F for fourth harmonic is equal to 4 times of V by 2 into length of organ pipe. They are asking length, they are asking. These two are equal, so you can just equate these two. 9V by 40 is equal to 4V by 2L. To VV cancel, 2 table 2 times cancel, cross multiply, 9L is equal to 80, and L is equal to 80 divided by 9. That's F correctly represents the variation of resistivity with temperature. See, basically they want resistivity and temperature relation. So we know rho is equal to rho naught into 1 plus alpha delta T. So directly you can go for this option because it is somehow it is, you see, with relation, directly relation with the temperature. So it is like y is equal to mx plus c you will get if you solve. This is the answer, fourth option. Solve it. Rho is equal to, if you solve, rho naught plus rho naught alpha delta T means T minus T naught. Again you solve. Rho is equal to rho naught plus rho naught alpha times of T minus rho naught alpha T naught. Somehow you got rho is equal to rho naught alpha T plus rho naught minus rho naught alpha T naught. It is in the form of y is equal to mx plus c. So straight line. If the VDSC apparatus is immersed in the liquid, okay, when it is immersed in the liquid of refractive index mu, what is the fringe width, how it will change? See, fringe width formula, lambda capital D by small d. Capital D do not change, small d do not change. Distance between the screen, and lambda, yes, lambda depends upon the refractive index. Yes or no? When you immerse in the lambda is equal to lambda naught by refractive index. So when you immerse in the any liquid whose refractive index is mu, then mu times it will decrease, lambda will decrease. So of course the width also 1 by n, it is first lambda capital D by small d. 1 by n times the width will decreases. Width increase, fringe width increases, no, fringe width decreases, remain unchanged. It may increase, no. The option is, second option is the correct answer. Two spherical black bodies of radius, first one, second one, at temperatures first one and second one respectively. What is the ratio of the rate of heat loss? See, every body radiates energy, Stephen's law. dq by dt, rate of radiation, heat loss, is equal to sigma EA T power 4. Sigma is a constant, Stephen's constant, E emissivity. Black body, so it is 1. Area, surface area of the sphere, 4 pi r square, temperature given. So this ratio they are asking. So the first one, dq by dt, by second one, dq by dt. First one and second one. Okay, chalo. First one formula, see, sigma will cancel, E will get cancelled, area 4 pi will get cancelled. See, first one radius 4 pi r square, I am putting here, so sigma E area 4 pi r square. Okay, chalo, r1 square t1 power 4 by sigma E A 4 pi r2 square t2 power 4. See, sigma E 4 pi get cancelled. So it is left with r1 square. What is r1? Radius of first one, 0.8 by, I can write r2, 0.2, these two whole square, a square by b square, a by b whole square, and t1 by t2. What is t1? t1 is 400 by t2 is 800 power 4. See, point cancel, means you can multiply with 10 and 10. 2 table 4 times, so you got here 4 square 16, 0 0 cancel, 0 0 cancel, 2 4 table 2 times 2 power 4, that is 16. So 16 by 16, answer 1, option 4. Light of wavelength 550 nanometer. Okay, wavelength given. Instead on the surface of, okay, cesium and lithium, I think it's cesium and lithium, work function are given, the electron will be ejected. See, if the energy is greater than work function, then the electron will be ejected. Basically, energy should be greater than the work function. Find out energy, E1, first one. Now, basically find out energy, E is equal to Hc by lambda. One more formula, 1242 by lambda. Lambda should be in nanometer. Energy will get in EV if this formula you use. Then it is 124, better you can take it as approximately 1242 by 550. So 1150 times 11 ones are 1 will be 11, this will be 32 up 2 times, okay, 5 tens are 5 twos are 10, 5 twos are, so how much you are getting? You are getting 2 point something, right? 2.2 approximately, you got 2.2. So it is, see, here the energy is equal to 2.2 EV is incident on the surface, whose work functions are 1.9 and 2.5. See, this energy is lesser than this work function, so the electrons, second metal, that is lithium, do not liberate, cesium will liberate. So answer 1, cesium only. Of the thin combination of lenses. Okay, here you see first lens, second lens, third lens, 3 lenses are given. Okay, let's do with the 3 different color. This I will do blue, this I will do with purple. Okay, fine. So first one, so first lens, there is a plano convex lens. This is the first one. You see, I am doing this for first one, this second one, third one. Power 1 by f, we have formula, 1 by f is equal to focal length. Okay, n of lens minus by n of surrounding minus 1 into surrounding is 1 only, don't worry, 1 by r1 minus 1 by r2. So this is the basic formula we have. So see, this is the radius of curvature R1, this is R2. R1 is infinity and R2. If you treat this direction as positive, then R2 will be, you need to go opposite to it, right? R2. Now, this is the radius of curvature, right? You need to go opposite to it. So you are going opposite to it. So this is negative. Chalo, substitute. N of length how much given? 4 by 3. Surrounding will be 1 minus 1 into 1 by infinity minus 1 by this is R1 given, showing R1. So solve it, you will get 4 minus 3, 1 by 3. It is minus of minus, it becomes plus into 1 by R1. Chalo, this is first one. Now in the same way we will do second one. If you see second one, this is biconcave lens. This is the positive direction and you need to go for R1 in this direction. So R1 is negative, R2 in this direction, so R2 is positive. Chalo, and given this is R1, this is R2, perfect. Refractive index is 3 by 2. Same formula, 1 by f2 is equal to, apply, n of length 3 by 2, this 3 by 2 minus 1 into 1 by R1 minus it is minus R2, 1 by R2 positive it is. So overall I get 1 by R2 is equal to 3 minus 2, 1 by 2 into 1 by minus, you can take common, minus R1 plus 1 by R2. So keep it as it is. Now third one I am solving. Third one is a convex plano convex. You can take any way, it doesn't make any difference. You can treat the lens like this also. Chalo. Now this is my lens. This is my R1 positive because you are going on a positive side direction, and R2 will be infinity, plane it is. So 1 by f3 is equal to lens refractive index 4 by 3. So 4 by 3 minus 1 into 1 by R1. 1 by R1 is positive. Of course minus 1 by infinity it is 0, fine. So you got 4 by 3, LCM 4 minus 3, 1 by 3. So 1 by f3 is equal to, it is 1 by 3 times of R1. So finally altogether 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3. By substituting 1 by 3 R1, 1 by f1 is 1 by 3 R1, 1 by f2 is this, minus multiply 1 by 2 R1 multiply minus 1 by 2 R2 plus 1 by 3 R1. LCM you take, LCM is 6 R1, R2 is the LCM, 3 2s are 6, 2 R2 LCM, 2 R2 here, minus here 3 R2 minus 3 R1 plus 2 R2. So overall it is minus R2 minus R1 by 6 R1 R2. By 6 R1 R2, two options there, here minus there, so third option is the correct answer. Thank you. Mass M, radius R. This is a mass M, radius R. Cavity has cut of R by 2. Cavity has created R by 2. Find the moment of inertia about the center of the sphere. Okay, fine. So I final, this is I of without cavity, let it be I total minus I of cavity. So first without cavity, with cavity. Consider there is no cavity at all. So moment of inertia passing through the center formula 2 by 5 mr square. Total mass is m r square. So what is this value? This value we got IF is equal to, without cavity we got 2 by 5 mr square minus I of cavity I want. So you made a cavity of r by 2, right? I of cavity is equal to
It is also 2 by 5, but mass is not capital M, it is some mass that we will find out. mr square r by 2 given r square. So I want this is small m, mass is equal to density into volume of the cavity. I know the density, density is equal to, see what is the density, this is mass, this is radius, right? Density is equal to total mass by volume of the sphere 4 by 3 pi r cube. This is the initial density. From that density I want, this is the volume of the mass we have, right? Again 4 by 3 pi r cube by 2 cube 8. This is volume of the cavity. 4 by 3 pi r by 2 whole cube, r cube by 8. See 4 by 3 pi r cube, this 4 by 3 pi r cube cancel. So small m I got is capital M by 8. Substitute here. This is 2 by 5, capital M by 8, r square by 4. 2 table you can cancel 2 times. Finally I got cavity in the moment of inertia mr square by 8 by 40, 80. So I moment of inertia or something. I think this is the answer. Like chalo, do it. This is cavity. How much we got? mr square by 80. So 80 is the LCM. 16 to the 32. 32 mr square minus mr square. This is 31 mr square by 80. Option 2 is the correct answer. The capacitor has charged by battery to a charge of Q1. Now the battery is disconnected. Battery disconnected, there will be no loss of charge, and dielectric slab K is inserted between them. Now the charge in the capacitor is Q2. What is the ratio? See, Q1 is equal to Q2 because there is no battery connected, there will be no discharge, there will be no charging. So the ratio will be 1. Electron entering the space between the plates of a parallel plate capacitor. See, the electron is entered in the space of the parallel plate, between the parallel plate capacitor, with an initial velocity. See, Vx given. It's like a projectile, you see. It's a two-dimensional body. Vx is there, Vy there. Vx given. Vx given, underline it. Parallel plate plates. If the length of the plate is 10 centimeter, electric field given, electric field is in the y direction given, okay. Then the value of Vy when the electron comes out of the plates is okay. See, Vy is changing because of this electric field. Because of electric field, acceleration will be F is equal to Eq. Basic formula. F is equal to Ma. A is equal to mu if you transpose Eq by m. So this is the acceleration which is opposite to y. Correct? So V is equal to U plus AT, general formula you apply. Okay. Uy will be 0. Okay. Uy will be 0. And opposite not, it is attracting. See, electric field attracts the electron in the opposite direction. Because of this acceleration, the electron is moving. Initial velocity was 0. So Vy will be Uy 0. Ay is Eq by m. It in the time t. So what is the time it will travel? The time is required out. It will come out of this 10 centimeters, right? Until that it have acceleration. That time you find out. For x direction you apply the velocity, no? So you want time. S you know, Sx you know, 10 centimeters. Okay, and Ux we have initial velocity, acceleration 0. There is no acceleration in the x direction. So S is equal to ut plus half at square you can apply. S is equal to ut, a value 0. So this is 10 into 10 power minus 2 is equal to ux value 10 power 6 into time t. So we got the time. So time is equal to, this is 10 power minus 1, 10 power minus 6, 10 power minus 7 it is becoming. Okay, seconds. Got them? Substitute here. Vy, electric field value given 9.1, Q value 1.6 into 10 power minus 19, 1.6 into 10 power minus 19. Mass of electron we know 9.1 into 10 power minus 31 kg into time we know 10 power minus 7. So 9.1 9.1 cancel, 10 power this is total become 10 power minus 26, here cancel, 10 power minus 26 10 power minus 5 up 10 power plus 5 becomes, so 1.6 into 10 power plus 5, okay, meter per second. Adam, second option. Particle shown in the figure is just able to complete, is a very important point, because see, if it is just able to complete, here the velocity is root 5 rg, okay. Circular vertical circular motion, find the ratio of the kinetic energy at A and kinetic energy at B. So, energy conservation you do, let this point be P, total energy at P, total energy at A, total energy at B are all are equal. So first what we will do, total energy at P is equal to total energy at A I will do. Total energy at P, see this is the reference point we will take, ground, so potential energy will be 0 at this point. So it have only kinetic energy. So at P we have only kinetic energy at P is equal to, at A, yes, it has some height. See, if you see, so this is the height it have, right? So you can see, so this is the height it have. I have to find out this height. This is radius. Radius is given, not given. Okay, no problem. See, and this is also the radius. From here to here it is r. Total is r. This is r. This is total r. This is h. If I say, this is, I can say r minus h. Total is r. This is r minus h. Theta, you know. Apply cos theta, adjacent, hypotenuse. So what I will do here, I will apply just a cos theta in this triangle. So just apply cos theta. Cos theta formula, adjacent by hypotenuse, adjacent is r minus h, hypotenuse r. Cos 60, 1 by 2 is equal to r minus h by r, cross multiply, r is equal to 2r minus 2h. So I can say 2h is equal to 2r minus r. So r is equal to, something went wrong, 2h, this is r. H I want, right? H is equal to r by 2, perfect. This is at a height of r by 2. I got the height. So here we have potential energy at A plus kinetic energy at A. Now we want kinetic energy at A. Kinetic energy at A is equal to kinetic energy formula at P, kinetic energy at P minus potential energy at A. We got something. Chalo. At A height we found, we can substitute kinetic energy formula half m v square, v is root 5 rg, v square is 5 rg, minus potential energy m g h r by 2. So this value I got. Chalo, I will keep this aside. Okay. So this solution I'll keep it here. Fine. Solve it. So 2 LCM, 5 minus 4 mRg, 2 times cancel, 2 mRg is the kinetic energy at position A. Same way position B we will solve. Okay. At position B also same, total energy at P is equal to total energy at B. Total energy at P, we have only kinetic energy at P, that is kinetic energy at P is equal to potential energy at P plus kinetic energy at B. So let's B. So this is the height. So we have this much height. So this is R, okay, R plus something. So this we have to find. Let it be, this is something y you take. Okay, r plus y is the height. So first find out y, apply cos theta. Cos theta is equal to here this triangle BPQ, B something this is P, something this is Q, BP cube. Adjacent is Y, hypotenuse is R. Cos theta 1 by 2, cos 60 1 by 2. So Y is equal to R by 2. Y value we got R by 2. This total height at B, H R plus Y. So capital H is equal to R by 2 plus R. So capital H is equal to, I got 3R by 2 is the height. Substitute here. So this is half mv square. Okay. We want kinetic energy of B. So I can say kinetic energy of B is equal to kinetic energy at P minus potential energy at B. Potential energy at P. Kinetic energy formula half mv square. V square is 5rg minus potential energy formula mgh. H is 3r by 2. So 2 LCM you take. 5 minus 3, 2 mrg. 2 to cancel. Finally I got kinetic energy at B is equal to mrg. They want ratio of A and B. So this is A at 2, B at 1. 2 is to 1 is the ratio. Final answer is 2 is to 1. So answer, kinetic energy at A by kinetic energy at B is equal to 2 is to 1 is the required answer. That's it. Thank you. Current drawn from the battery in the circuit is simply current they are asking. I is equal to V total voltage by equivalent resistance U2. Voltage is given 0.9 by equivalent resistance. If you find sum completed. See, for equivalent resistance you see there is one resistor there, and here this is a variable resistor. Rheostat is kept at the midpoint. When it kept at the midpoint, you can take it as half of. Resistance will be equally divided because length is divided. R is equal to rho L by A. L is half. So this becomes 0.5. This becomes 0.5. And here 2 ohm resistor there. Here there is one resistor. 2 ohm resistor. So you want equivalent resistance across the terminals. Correct? This is A, this is B. First these two are in parallel. R1 R2 by R1 plus R2 you apply. Okay. So what I will do, so these two are in parallel. Take these two first. These two becomes one resistor and there is 0.5 in series finally. So this value we have to find out. This value is 0.5. Formula R1 R2 by R1 plus R2. R1 is 2. R2 is 0.5 means 1 by 2 by R1 plus R2, 2 plus 0.5. So it will be easy, right? That's why I kept like this. So it is 1 by 2.5. Simply it is 5 by 2. We can get it 2 by 5. This is 5 by 2. 5 by 2. 1 by 5 by 2 means 2 by 5. Now, this value, these two are in series. These two together you can treat it as one resistor. Together you can treat it as one resistor. Final answer will be that. So the final answer will be of one resistor, that is 0.5 means 1 by 2. This is how much it is, 5 table, 0.4, 5 ones are 5, 4, 0.4. 0.4 plus 0.5. Answer 0.9 ohm is the equivalent resistance. Substitute here 0.9, 0.9, 0.9 cancel. So I is equal to 1 ampere current flows in the circuit. Okay, there is a convex lens out there as shown in the figure, is silvered with one side. When it is silvered one side, it behaves like a mirror. For what distance of object from the lens is the image formed on the object itself? See, here is an object is there. So the rays will go, see, these are the rays. So refraction will take place. Again they will come back. Let it be something. Image also formed at the same position. Exactly it behaves like a mirror. Now it is a combination of how there is a convex lens, biconvex lens there, and there is a mirror there. So the light ray traveled from the convex lens, refraction takes place, reflection takes place, again refraction. So two times it is passing through lens and one time it is passing through mirror. So 1 by F equivalent. So finally the F equivalent will be, so we want F equivalent because it's a combination of lens and mirror. So we need to find out 1 by F equivalent. First lens there plus mirror there, again lens there. Overall it behaves like a concave mirror, so here minus, and here also for concave mirror 1 by F equivalent will be, F will be minus. Power of lens is equal to individual powers you should need to add. So lens formula 1 by F, FL, focal length of lens formula, just apply the focal length of the lens formula. 1 by F of lens is equal to N2 by N1, N2 is the refractive index of the N of lens by N of medium, medium is 1, minus 1 into 1 by R1 minus 1 by R2. Here let's substitute. Lens is mu given, medium is not given, by default it is 1, and R1 R2s are equal. See, R1 is the first surface, so this side is positive. So R1, if you see, it is in positive side, so this is the positive side. If you form, it will form a circle here, sphere here. So R1 is this side positive. R2 forms a sphere here, somewhere here, so R2 will be negative. So if you see here 1 by R, minus of minus plus 1 by R. So what do you get? R is the LCM. So it is mu minus 1 into 2. That is lens. Just substitute here. Minus 1 by F equivalent is equal to, lenses 2 are there. So I can say 2 into FL, 2 into 2, 4 it becomes. So I can say 4 into mu minus 1 by R minus. Now focal length of mirror formula. What is the formula for mirror? Focal length is equal to, focal length of mirror is equal to 2 times R by 2. Now mirror where there? Opposite direction you need to move, see. Opposite direction. So it is minus R by 2. So reverse it becomes minus of minus plus 2 by R. So what it becomes? Minus 1 by F equivalent is equal to R LCM, 4 refractive index minus 4 plus 2. Minus 1 by F equivalent is equal to 4 times of refractive index minus 2 divided by R. Okay. So finally it behaves like a mirror. So mirror formula you apply. 1 by F equivalent is equal to 1 by B plus 1 by U. Okay. Focal length is negative. So mirror it is, and object distance also be negative. Sign convention I am applying always, and image also on the same direction there, you see, minus. All three are minus, you can cancel it. So 1 by F equivalent value, 1 by F equivalent is equal to, you can substitute here, minus 1 by F equivalent, 4 mu minus 2 by R is equal to 1 by U plus 1 by U. 4 mu minus 2 by R is equal to U LCM 2. 2 you can cancel. So 2 mu minus 1 by R is equal to 1 by U. So finally U is equal to 2U minus 1. R by 2 reciprocal you do na? R divided by 2 mu minus 1. That's the third option. Vernier calipers. One vernier scale division is smaller than one main scale division. Absolutely correct. That's why vernier calipers, vernier scale is used for higher precision to calculate the smaller values. So this is true, undoubtedly. Next, the vernier constant is given by one main scale division multiplied with the number of main vernier scale divisions. No, it is wrong. There is no multiplication. Least count is 1 main scale division minus 1 Vernier scale division. Okay. A parallel plate capacitor of capacitance 40 microfarad is connected to 100 volts power supply. Now the intermediate space between the plates is filled with dielectric constant K equal to 2. Due to the introduction of dielectric, the extra charge of course and change in electric energy, electricity energy in the capacitor respectively. Okay, they are asking extra charge, delta Q and delta E they are asking. Okay, fine. Due to, see, basically there is a capacitor, what they want to say. So there is one capacitor and this capacitor is connected to 100 volt battery, correct? Or battery, capacitor value 40 microfarad. So initially charge is C is equal to Q by V, Q is equal to C into V. C value 40 micro into 100. So basically you will get Q is equal to 4 into 10 to the power of 1 to 3 gone minus 3 coulombs. Okay. So this much coulomb there initially, first initially, and energy is equal to half, yeah, we can apply CV square, half into C value 40 into 10 to the power of minus 6, V square 10 power 2 square 10 power 4, 4 5, this becomes 2 times, this becomes I think 2, 0.2 it is, 0.2 joules. This is 10 power 4, 10 power minus 1, 2 left, here 10 power minus 1, okay fine. See, charge I got, electric energy I got initial case. Now what they did, they filled the dielectric in it. Now C increased by K times, okay. K value 2, C value 40 microfarad. So it becomes 80 microfarad. Now they are asking Q. Q dash, Q new will be C into V. Double it became, you see, 2 times it becomes 2 into CV it became. Now here CV, here 2 times of CV. Means how much is the change? Change will be final minus initial, right? This will be final minus initial. 2 CV this is, and this is CV. अरे ऐसा ना, इसके otherwise you calculate. So this is 2 times it became 80. Let's do it. Chalo. So Q final is equal to C into V. New C value is 80 micro, 80 into 10 power minus 6 into V value 100. So it becomes 8 into 10 to the power of minus 3 coulombs. So delta Q will be Q final minus Q initial. Q final 8 into 10 power minus 3 minus 4 into 10 power minus 3. Basically you will get 4 into 10 power minus 3 coulombs, 4 milli. 4 there is only one option there, third option is the correct answer. Just to check with energy also, E final is equal to half CV square, half into C value 80 micro, 80 into 10 power minus 6, V square 10 power 4, 564, 0.4 joules it is. Delta E is equal to E final minus E initial. E final 0.2 and E initial 0.2. So finally 0.2 joules. Correct. When an ideal batteries are connected in parallel, then the resultant EMF is lesser than either of the batteries. See, when they are connected in parallel, what is the formula? E final by R internal resistance is equal to E1 by R1 plus E2 by R2. There is no guarantee that it will be lesser than either of it, both of it. Chalo, okay, let's take an example. It can be equal also. when both the ideal batteries are connected in parallel, the resultant resistance of the internal is smaller than either. This is correct. See, when they are connected in the parallel, their internal resistance will be 1 by R1 plus 1 by R2. In resistance in parallel will be always smaller. So second statement is true. When both ideals are connected in parallel, the resultant resistance of the internal resistance is smaller than the either of the resistance. Second is true. So second is true. First one is false. You cannot say first one is true. Okay. Of thermal conductivity K1, K2, K3 are given. Okay. The temperature at the leftmost is 100 degrees Celsius and the rightmost is 0 degrees Celsius. Okay, K1 value, K2 value, K3 value given. What is the temperature theta 1? It's like, see, you consider whenever these questions are given, each conductor as a resistor. So here is one resistor there, here is one resistor, both are connected in this way to, this is 100 volts. Temperature means voltage you consider, and here one resistor is there, here it is connected to 0 volts. Now they are asking the temperature here, that means voltage you can calculate here. Okay. Chalo. So conductor, so we want KCL you apply, current entering is equal to leaving. So let it be I1, I2, I3. So I can say I1 plus I2 is equal to I3. I is equal to V by R. So potential difference 100 minus V by, here you need to find out R. Okay. R is equal to formula L by K A. R is equal to rho L by A, we know. 1 by rho is conductivity, L by A. Okay. K is, you can, this is R1 you want. Okay. L1 is, what about the lengths? So lengths are half, shall we take the middle point, rightmost, and the temperature theta 1 will be. Okay. Areas are A by 2, this is L by 2, L is L by 2, conductivity given, K1 how much given? 60 given, area also half there, A by 2, 2 to cancel. So I got this R1 value. In the same way, find out R2, same method. So for R2 also, L is L by 2, K is 120, area is A by 2. So 2 to cancel, I got this R2. Here R3 also you can find out in this way. R3 is equal to L is L by 2, half there. So this is the length of the conductor into K3 value 135 given. Area is full area it is. So this is the value I got. Fine. Here substitute. I is equal to potential difference by R. R1 value L by 60A, L. So it is L into by 60A becomes into 60A plus I2. Potential difference same 100, this is also 100 minus V by R. R2 value, this is L by 120A is equal to I3, same I is equal to V by, potential difference is V here. Potential difference, current always travel from higher potential to lower potential. So V minus 0 by R. R is L by 135 means 270, it is 270A. So what is common there? You can cancel L cancel, A cancel, 0 cancel. Basically I left with a 600 minus 6V is equal to 600 minus 6V is equal to, sorry, plus there here, plus 1200 minus 12V is equal to 27V. So here 1800 minus 18V is equal to 27V. minus you transpose even plus, it becomes 27, 35, 45. 45V is equal to 1800. 9 table, 9 5s are 9, 200. 5 table 40. So basically 40 degrees Celsius is the, so V value we got 40 volts, which is nothing but 40 degrees Celsius is the answer. A particle is projected with velocity 60 at an angle of 30 with respect to horizontal. It reaches height h1 in the first second and height h2 in the last second during its motion. Find the ratio of h1 by h2. Arey, h1 by h2 will be equal. See, the distance traveled in the first second and the last second. It's like a body you thrown up and fell down. So how much time it will take to go up, that much time it will take to come down, right? Its ratio will be 1. Ratio will be 1.